as we know, the technology has grown at extraordinary rate in the last century. So transforming everything from industrial processes to how the people behave and interact with one another. So the fast advancement of the electronics and computer technology has altered how technicians and engineers approach temperature management. Yes, temperature management, how we cool the electronic devices. So today we will discuss the topic, which is the electronic cooling. So electronics that are spider, compact and more powerful, generate more waste energy, which must be carefully handled. Heat exchangers have emerged to provide the superior temperature management system required to efficiently cool contemporary devices to meet these problems. So, keeping in that mind, so we discuss the topic electronic cooling. So, what is this electronic cooling? Just to cool down the electronic circuit by the various technology. So, cooling technologies that have evolved in the steps to remove increasing levels of heat dissipation and manage junction temperature to achieve goals for efficiency, cost and reliability. So, cooling technology rely on heat spreading and convection in applications that use the natural or forced air cooling. Water heat pipes provides efficient heat spreading for size and weight reduction. So, power electronic devices such as MOSFET, GTO, IGBTs, IGCTs, integrated circuits are now widely used to efficiently deliver the electrical power in the home electronics, industrial devices, telecommunication, transport, electric grids and the numerous other applications. So, keeping in that mind, we will discuss why we require the electron cooling. First, we discuss why do electronics get hot. Surprisingly, the reason both the hard working computers and the light bulbs get hot and why any electronic devices get hot, which is due to the electrical resistance. So, electrical resistance occurs when electrons move through a material as a result of a charge imbalance. Because of that, electronic devices become hot. So, the movement of these electrons through a material creates friction between the moving electrons and usually crystalline structure of the material. This large amount of friction result in the excess of the heat and often requires secondary cooling methods. So, in modern technologies, the highest thermal energy producing components are LED and processing units, which we are having GPU, CPU and the TPUs. These units just have the highest thermal energy producing components, so which are made using the semiconductor materials. So we can also find out high thermal energy in the voltage changing devices such as resistors, transformers, converter, inverters. So CPU heat generation and the system that help control these chips temperature is what cause the fan cooling system of a laptop to initiate and run during the operation. As you all see in your desktop and in your computer, there must be a cooling fan which just maintain the temperature of the laptop as well as the desktop. So these air coolers, air fans just installed within the CPU as well as in the computer as well, so that it will cool down the temperature of the device. So, electronic cooling. What is this electronic cooling? Electronic cooling refers to the method used to dissipate heat generated by the electronic component and the system to prevent overheating and ensure the reliable operation. So, just we maintain the temperature of the device so that the device can work in a reliable manner. So this is crucial because excessive heat can degrade the performance, reduce lifespan and potentially lead to the failure. Moreover, it can damage the wire, it can damage the other devices which is in the circuit. So cooling of a device is very important. So for this we have many techniques. Moreover, electronic cooling refers to the methods and technologies used to remove the excess heat from the electronic devices and the component and preventing overheating and ensuring the optical performance and the longevity of the device. So this is crucial because the overheating can lead to reduce the efficiency, malfunctions and even permanent damage. Common technique include the air cooling and liquid cooling and the thermal electric cooling. So there are the various methods. So another question which we have in the mind, that why is electronic cooling essential? Why it is essential? Just the single point is that just we save our devices. We can make our device for a long life. So generally an electronic device consists of many different kinds of the components, as we know. So out of these, each electronic component has a thermal limit, which is its maximum operating temperature. So if this is reached, the component will burn out. So a threshold temperature is associated with every device. So the maximum operating temperature is required for a device to work. So if this is reached highest, then the component will be damaged. Consequently, failure to properly manage such heat is electronic component and microprocessor can lead to the destruction of the circuit board and finally a system malfunction of the entire device. Therefore, to keep the circuit operating stably so that the device's lifespan can be extended. So the device must be equipped with a measure to remove the heat generated by the device. So the device must be equipped with a measure to remove heat generated by the device. So we require the cooling methods or the cooling technology. So heat dissipation is one of the problem. Second is the electronic component generate the heat as byproduct of their operation. This heat needs to be efficiently removed to maintain a stable operating temperature. So as the example is very clear, in the daily life we are having the CPU and the laptop having a air fan, so that it can performance can be increased. So why is electronic cooling necessary? The first is heat dissipation. Electronic component generate the heat as byproduct of their operation. So this heat needs to be efficiently removed to maintain a stable operating temperature. The another point is the performance and reliability. Exceeding safe operating temperature can lead to the performance degradation such as reduced processing speed or increased error rates. And the third point is a component lifespan. Just we want that our device will work for a longer time. So for that, high temperature can accelerate the aging and degradation of the electronic components, shortening their lifespan. How can we remove heat? What kind of methods and components can be used for cooling the electronics? Placing a focus on this point, this entry describes the cooling methods and the components. So how to optimize an electronic design? How we can optimize the electronic cooling designing? Number one, identify the best cooling solution. So what are the optimal conditions so that we can have the good electronic cooling methods? First is the identify the best cooling solution. Electronics designers have multiple options to keep their product cool. So, would passive cooling be enough to prevent the thermal damage, or is an active cooling better despite its energy cost and the noise concern? So, first we have to choose which is the best cooling solution for a particular application or a particular devices. Another is the find the right placement for fans and heat sinks. Fans and heat sinks are widely used in the electronic or the heat dissipation. So, it is important to optimize the fluid path and ensure that the heat sinks are placed in such a way that they do not impede the internal flow. So, the placement of the fans and heat sinks are also on the right place. So, the visualizing the airflow and the temperature distribution around the component in the electronic enclosed helps to identify the best possible placement of the fan and the heat sinks for a more efficient cooling process. The third point is the test enclosure dimensions, where we are using this cooling device. So, physical size of the enclosure is the primary factor in determining its ability to dissipate the heat, making it fundamental factor in the thermal design. So, the best dimensions of an electronic enclosure and ensure the effectiveness of the cooling strategy for the semiconductor is an important part. Number fourth part is the validate material decisions. So, what material we use for preparation of the electronic cooling devices? So, materials thermophysical properties can largely determine a product's thermal performance. So, making them an important factor in the electronic devices. The thermal conductivity of the copper or the silicon can be changed over the expected range of the operating temperature. So, thermal analysis enables engineers to validate the material decisions and test their conductivity for a fast cooling process, keeping semiconductors cool enough to prevent the failure. Another point is the ensure energy efficiency. The increasing energy costs and the need for reducing the energy consumption are driving the demand on not only efficient but also energy efficient cooling solutions. So, ensure the energy efficiency, identifying the optimal thermal management solution for a specific product, be it active and the passive cooling, compare design and the eliminate excessive components. Another we will discuss that what are the electronic cooling methods. What are the electronic cooling methods? Basically, electronic cooling methods can be broadly categorized into the active and the passive cooling. Means we are having the two methods, one is active method, second is the passive cooling method, and then the further divided into the various techniques like air cooling, liquid cooling, heat pipes and the thermoelectric cooling. These methods are used to dissipate heat generated by electronic component, preventing overheating and ensuring optimal performance and longevity. So, what is the difference between the passive and the active cooling? Here we are having two type of methods of the cooling. One is the passive and another is the active. So, cooling strategies can be divided into the categories like applied depending on the product configuration, noise consideration and energy efficiency goals. So, what are the basic type of the active cooling and passive cooling? You see on the screen that here we are having the active cooling. So, active cooling relies on the external device and the use of energy to induce heat transfer. Through the active cooling technologies, the rate of fluid flow increases during the convection, which speed up the heat removal rate. You see that here having the active cooling, which is relies on the external device and the use of the energy to induce heat transfer. So the advantages of the active cooling are significantly higher efficiency in the heat dissipation and the faster result. These solutions include fans, liquid cooling system, or the thermoelectric coolers, and which can be used to optimize the thermal management on all levels and reduce the failure risk. So another type of cooling is the passive cooling. So in the passive thermal management refers to the cooling solution that rely on the thermodynamics of the convection. So convection and the radiation for the heat transfer. The main advantages of the passive cooling are energy efficiency, which is used for the noise reduction, easy implementation and the low cost. So this techniques utilizes the heat spreaders, heat sinks, heat pipes and the thermal interface material, that is a TIM, to dissipate the heat and maintain the optimal conditions. Operating temperature for the electronic devices. So active cooling, this type of the cooling relies on the external power to enhance the heat transfer. For example, in the active cooling we are having various methods just for the cooling the electronic devices. The first is the forced air cooling. First is a forced air cooling, or sometimes we call it as a air cooling. So fans or the blowers are used to circulate air over the heat sinks or directly over the electronic component, increasing heat dissipation. Another type is the liquid cooling. As the name suggests, we use the coolant. So coolant like the water or the specialized liquid. You can see in your houses that sometimes the inverter require the water. So we put the water in our inverter batteries. So coolant is also required for the cool down the batteries. So liquid cooling contains a coolant, and this is like a water or specialized liquid and is circulated through a system to absorb the heat and dissipate it elsewhere, often through a radiator. Another type is a thermoelectric cooling, that is most commonly used, and using the Pelleter effect, these devices can transfer the heat from one side to the another side by applying an electric circuit and creating a hot and cold side. Another is the vapor compression cooling, and this method uses a refrigeration cycle, that is compressor, condenser, expansion valve and evaporator, to cool the component. So these are the vapor compression cooling. Another type are the passive cooling. So this method relies on the natural heating transfer mechanism without external power. Example are the natural convection. Heat is dissipated through the natural movements of the air due to the temperature differences. So here we are having a various method. In the short we will discuss first, that is a heat sinks, that devices with the extended surfaces designed to increase the heat transfer through the conduction and the convection. Another is the heat pipe, which is a device that transfers the heat efficiency through the evaporation and the condensation of the working fluid within a sealed enclosed. Another type is the phase change material cooling, that is also called as a PCM cooling, and using the material that absorbs the heat by changing the phase. Like solid to the liquid, PCM can provide a buffer between the temperature spikes. Another is the micro channel cooling, and this utilizes the tiny channels to circulate the coolant and remove heat from very small electronic devices. So micro channel coolings are used in the nano devices also. Another is a jet impingement cooling. So directing a jet of the liquid at a heat generating component to activate a high heat transfer rate. So by using this we can achieve the high heat transfer rate. Another cooling techniques are, number one is the conduction cooling, that is the heat is transferred through the direct contact between the component and the cooling medium like a cold plate. Another is a radiation cooling, heat is dissipated through the electromagnetic radiation. So these are the various cooling methods. We will discuss these methods in detail, as the cooling methods are classified according to the mechanism and the medium used to transfer the heat during the cooling process. So on the basis of that, despite of the impressive progress made on the electronic cooling system in the recent years, the required high heat flux removal from the high-tech electronic devices remains inadequate and very challenging. So there are a number of cooling methods widely used in the electronic industries. So based upon the heat transfer effectiveness, the existing cooling modes can be classified into the 4 journals. Number 1 is the natural convection, second is the forced convection, that is the air cooling, another is the forced convection, liquid cooling, and another is the liquid evaporation. So based on the approximate range of the heat flux removal rate, so what we are doing in the electronic cooling is the heat flux removal, and that we are calculating the heat flux removal rate of these methods is known as, it is known that liquid evaporation is the best techniques, followed by the forced convection of the liquid, and then in addition to the above general categories based upon the coolant and the cooling methods, we have the several methods like air cooling, like liquid cooling, refrigeration cooling, and we will discuss these methods in detail one by one in the next lecture. Thank you very much.